Hey guys, in this video let me tell you about deleting at beginning or deletion at beginning. Okay, deletion of a node at beginning. First of all, how will you delete a node from the memory, guys? You have to use one function called free. I told you about this. It will deallocate the memory. So if you say free of temp1, it means it will deallocate this memory. Okay, it will what is mean by deallocating, which means that it will say temp1 is having the value 1001. It will deallocate the memory. You can use that memory again, but it will free the memory. Okay, as the name states, it will make the memory free. Okay, that's called deletion. Okay, it should be crucial. Okay, so 1002, I'll take the common example 1003. I told you for all the algorithms I'm going with the same example for your better understanding. Okay, and it will also be easy for you to recall. Okay, this is 1001. All right, so deletion at beginning means there will be a start pointer will be pointing to this node. You just have to delete this node, that's it. Okay, and after that your list should contain only these two nodes. After deleting this node, how it's possible? It's very simple. First make your start pointer, guys. Start pointer, first make your start pointer points to the next node. Okay, points to the next. This is very simple. You just have to manipulate the start pointer. Start equals to start points to next. Start equal to start arrow next. This will help you to jump one node. I told you that. So you make start equals to start arrow next. This will point to 1002. All right, and after that since there is no there is only one link. Okay, you can delete this. So using the free, and you have to pass this address. Okay, I'll tell you how to do that. So it's very simple. Deletion at beginning is very simple. Okay, and we'll implement. So that there are two crucial statements here. First, just store the start in the temporary variable, the initial start you have, start variable, which is pointing to this one. Just store this address because we want to deallocate that. Because okay, instead of before making start point to the next node, just store this address somewhere. So after that we can delete the address. That's why. So now temp will have the value 1001, right? After that you just manipulate the start variable. Okay, make start variable point to the next node. You can also say temp arrow next or start arrow next. After that you free temp1 or temp, because that is only having the address 1001. Okay, so it will be deleted. It will be pointing to 1002. Okay, free temp. I hope I made it clear. Let's implement this using C in the upcoming video. Alright guys, so in this video let's talk about the algorithm deleting at the beginning. Okay, so deleting at the beginning, that's the basic operation that we perform. So deleting the first element. Okay, let me go for this, deleting the first element. Alright, so it's very simple actually. So let me start from a clean code actually. In the insertion algorithm I have just copied some code, but here I'm not going to do that. Okay, if it seems like wasting your time, then you can forward it. Okay, so I'll say void main, and yeah, now I have the structure of the node. So it's very simple for me now. I'll just create a start pointer. So struct node start. Just for you to revise, I'm typing it again, right? Start and allocate memory actually. Or let me copy the code. Okay, it's very easy, right? You know this code. Okay, I'll have this code here. So these are my okay, so it's actually getting the creating a linked list and getting the values. Okay, let me copy this code. All right, so yeah, so what I'm basically doing here is, you know this code, right? We have seen this code a lot of times. Okay, I thought I could write it again, but the problem here is the time. Okay, so let me go for it directly. So we are just declaring some variables, getting the starting node, and getting all the nodes and linking them. Okay, abstractly I could say, but if you want a deep explanation, you can go and watch the first video on linked list. Okay. Okay, so let me go for in implementing deletion at the beginning. So what is the algorithm? I already explained that. So I'll just have to implement that, right? So here I will implement deletion at the beginning. First node should be deleted, that's it. You don't need a loop in this case, okay. You know there is no need to iterate, okay. You can directly delete the first element, but the idea here is make start point to start arrow next, okay, which means that jump one element and make your start point to that element, okay. In only rare cases we'll manipulate the start variable, right? Otherwise we'll be going for this temp one already, right? Yeah, always we go for temp one, but here I just want to delete the first element permanently. So I'm making the start to point to the second element. Start arrow next will point to the second element. So I'm making the start to point to the second element, and of course, let me do one thing also. I'll just say temp1 equals to start. So now the initial start value will be stored in temp1. So the first element will be stored in temp1, and now start will be asked to point the second element, right? And after that you can free the first element. I mean, you can make first element to be free. Okay, all right. So let me display the elements before and after the deletion, okay, so that you will be able to understand it clearly. So this is before deletion. I'll just say here, I'll say before deletion, all right, before deletion. And after performing deletion, I'll just copy the same code, okay. This is after performing deletion, and I'll say here I'll say after deletion, all right. So that's it, I hope. So let me run this code, let me check whether it works or not. As an error, I think, yeah, the struct there should be a semicolon here. Sorry, I'm making this mistake continuously, right? Sorry for that. Okay, so 3, 10, 20, 30. Yeah guys, there should be a new line here. I'm sorry for that. Okay, let me check the linked list itself. Before deletion it is actually 10, 20, 30 null. After deletion it's actually 20 and 30 because the first element is actually deleted. Okay, so that's the idea of having deletion at the beginning, and deletion at the end I leave it to you. It's almost very similar. I'll leave it to you. I'll already explain the algorithm in the next video, so please watch that video, and you can code it by yourself, right? All right, thanks a lot. Okay guys, let's talk about deletion at end. Okay, and this is something important and very easy too. It's very easy guys, okay, trust me. And yeah, you I will take the same example, 10,002. I hope it is not monotonous because we are implementing different algorithms using same example. I thought it would be interesting. It won't be monotonous, right? Okay, 1001. Okay, so deleting an n means you have to delete this node. That's it, right? How to delete this node? It's very simple. You have to make the previous node points to null. Okay, you have to make this previous node points to null. I mean, you have to delete this address. If this is null, means this is the end node, right? Then we can free the node. Okay. If this is null, means this is end node. But how it is possible? This is very simple guys. First you have to get the address of the last node, right? Whenever you are performing an operation at the end, you have to get the address of that particular node, right? So to do that, what should you do? You should run a loop until the last element, okay. Get the last element, store it somewhere, maybe temp1, just for an example. Say it is storing the last element. So what should you do? You should do temp1, right? So temp1, I mean, you have temp1. So what will you do? But you also have to get the previous element also, because the main idea here is making the previous element point to null, and after that deleting this. So you have to get the address of the previous element also. This is possible by these two statements. Temp2 equals to temp1, temp1 equals to temp1 arrow next. I'll explain this in the code. Don't worry if you don't understand this. These two statements are very crucial, which means that whenever you are iterating in a loop, from left to right, okay, first temp1, maybe temp1 is 1002. Let's assume temp1 is 1002. Then that will be stored in temp2 first. So temp2 will hold the value 1002, and temp1 will point to the next. Okay, this will jump to the next node, so temp1 will have the value 1003. Even if the condition gets false, temp1 still holds the previous value, and temp2 still holds the previous value, and temp1 will hold the next value. So whenever you are performing something at the end, if you are performing, then you use these two lines of code, okay, to get the previous element. You use these two lines of code. This will highly help you. Even if the condition gets false and it comes out of the loop, temp1 will be having the value of last node, and temp2 will be having the value of the previous node. Okay, so after that, it's very simple. Temp2 of next should be null, and okay, and free temp1. Okay, free temp1, last element should be made free. That's it. Okay, that's the concept of having deletion at end. I hope it is very clear. I'll implement that in the next video. Guys, in this video, let's talk about how to delete a specific node in the list. Okay, so I have the same code which we have used so many times. So I'm just going to modify the core algorithm to work for deleting a specific node. Okay, so I have before deletion and after deletion the printf statements to print the linked list. So here I can write my core. Okay, the code. So I'll say a comment deleting a specific node. All right, it's very simple actually. First of all, you just have to iterate, because you have to find which is your specific node, right? So let me get that from the user. Printf, enter the specific node which you want to delete. All right, enter the specific node which you want to delete, and yeah, enter the specific node which you want to delete, and get that, store that in the temp variable, because we have already declared that, right? So temp. All right, so let me start the loop. It should be starting from temp1 arrow next. Temp1 arrow next. Temp1 starts from start. No, we have to make that statement also. We have to make the temp1 starts from start. Okay, so temp1 is assigned to start. Start is something, the first element. So when starting from the first element, iterating up to the last element. But we don't want to go up to the last element, right? We want our loop to stop whenever the specific node is encountered, right? So in that cases, let me say if temp1 equals to temp1 of next equals to temp. Sorry, it's data, right? So temp1 arrow data in a particular node, in the data field of a particular node. If you get that temp variable, if you get that temp specific node, then break the loop. All right, break the loop. Else you just iterate. That's it. You just iterate. I'll be saying temp2 equals to temp1, and I'll say temp1 equals to let me explain it in a while. Wait a minute. Temp1 equals to temp1 arrow next. I think I have explained it in a video. You can go back and watch, but still I'll explain that here. I have not declared temp2 also. Let me declare that here. Okay, yeah, here it's there. I'll say comma temp2. Okay, so what we'll be having the second temporary variable. This is because when I want to delete a specific node, you just have to get the previous node also. Okay, that's very important. You have to get the previous node also, because you have to make that previous node to point to the node after the node that you're going to delete. Okay, because then only the link will be better. Okay, so what I'm trying to say here is, let's go to the paint. I hope I have explained the algorithm already, but let me do that again so that you will get the clear idea. I'll do this alone again. Okay, if you still have any doubts, you can go back and watch the algorithm. Anyway, this is node 1. This is our specific node. Let's assume this is our specific node which I want to delete. Okay, all right. So there is a connection, right? There is a connection between the nodes, the link. Okay, you know that, and you have the next field here. All right, so this is my specific node. Here this is 20. That's the temp value, right? If this is encountered, what I'm going to do here is I'm going to do temp1. Temp1 will have the address of this particular specific node, whereas temp2 will have the address of this previous node, guys. Why previous node is needed? Then only After deleting this node, you can link this node and this node. Okay, before deleting, you can link this node and this node, so that the linked list will not be affected, only this element is getting deleted. So for that purpose, I am having these two lines. Okay, but whenever you have these two lines in this order in the loop, you'll get the previous element also. Okay, previous node also. Temp2 will be having the previous node, and temp1 will be having the specific node. All right, so come back and you make your previous node to point to the next node first. So that's temp2 arrow next equals to temp1 arrow next. All right, I think you will be able to understand this. Okay, so what you have in temp1 arrow next, I'll just erase everything. So this is temp1, right? What you have in temp1 having arrow next, you have the address of this node. So I'm having the temp2 arrow next. Temp2 arrow next, I'm making it to point to temp1 arrow next. That is this node. Okay, so I'm making. So what I'm making here is, we understand that temp1 arrow next is this. Temp1 arrow next is here, which points to this. So this one is temp1 arrow next, and I'm making temp2, the previous node arrow next, to point to this. So the link is created now, so we can freely delete this. Okay, there is no matter of having that. Okay, so for that purpose, I'm having this statement. After that, I'll say free temp1. The current node can be deleted. Okay, that's it. I think that's it. It will work now. Let's go for that. Enter the number of nodes, again 3. I'll go with the same example, 10, 20, 30. Before deletion, enter the specific. It asks me for entering the specific node. I'll say 20. Yeah, you can see 20 is getting deleted here. You got 10, 20, and 30. Here you get 10, 30, and all. Okay, 20 is deleted. Okay, so that's how this algorithm works. Thanks a lot. Thanks for watching. Actually, hey guys, let me explain.